Hi, everyone. Let's get started. Welcome to the Stratum Techinar. I'm Brian O'Connor, and I'm here with Max Pudelko, who we both recently joined Intel from ONF, and we both serve on Stratum's TST. In today's Techinar, Max is going to start with a few recent updates to Stratum, some of the things that we've done over the past year and some of the more recent releases. Next, I'll be covering how we'll be extending Stratum to support the server. And then I'll cover some of the near-term community roadmap items for Stratum in the next couple of releases. We should have plenty of time for Q&A at the end. So if you have any questions, find the Q&A panel at the bottom of your screen and enter your questions there. We may pick those up as we go, or we'll just save them for the end and then go over them. So with that, I'll turn it over to Max.
All right. Yeah, thanks, Brian. And welcome to the Techinar from me as well. Let's start with a short recap here. At this point, Stratum is 9 releases old at a quarterly release cadence, with the newest release, 22.06, being released just last month. By now, the team has figured out the process by far and large, and new releases are mostly painless and pretty quick for us. We continue our live attached strategy, where new features and developments happen at the tip of the main branch, and we take regular snapshot of that tip and tag those as the aforementioned releases. Let's go over our supported targets and their state as of right now. On the Tofino ASIC, we have reached a stable base and continue to undertake active development to address the needs of projects. More details on the next slide. The Broadcom side is mostly stable as well and sees only minor maintenance fixes as of right now. The same goes for the v22 software switch target. Support for the Intel NP4 FPGA remains at a proof of concept level, and there's no active development efforts right now, but might change in the future. Things get a little more interesting with the new table-driven API, short TDI, which will open the door to a bunch of new and interesting targets. Both software ones like DPDK, but as well as hardware targets like Intel's new IPU series of devices. A lot more on that later in this Techinar. There we go. Like mentioned before, we're focusing on Tofino ASICs right now, with most of the development happening on that platform. With the latest release, we removed the old Stratum BF target, BF for barefoot. It was one of the first targets, and building upon the PI node library to bring the P4 runtime API to Tofino. While PI provided fairly easy access and convenient access to the ASIC in the beginning stages of the project, over time it became a little too unmaintained and too inflexible for our needs, so we had to drop it. Stratum BF is superseded by Stratum BFRT, which has full feature parity and can be used as a near drop-in replacement. So there's nothing lost really. It's really just more up-to-date version of the code with the same or more features actually. Only the P4 pipeline packing process needs to be updated a little, for which Stratum provides all the necessary tools. Speaking of BFRT, BFRT has reached a level of maturity in production hardening. So we are very comfortable using it in our projects like SD Fabric, Ether, and Pronto, as well as the smaller deployments at other users. We strive to keep up with the latest and greatest Intel P4 Studio updates. Right now, this means version 9.7 through 9.9. Those include both an LTS version, long-term support, and as well as the latest release. So the latest and greatest you will be able to use. As a new feature, we're looking to implement table entry timeout notifications on Tofino. This is a very valuable feature for use cases like NATs and firewalls in P4. Additionally, this is really a complementary addition to the add-on miss feature of the portable NIC architecture, short PNA. The rapid automatic insertion and deletion of table entries is desired and actually required for full operation. So as you can see, we're both keeping up to date and adding new features as we go. Let's look at one of the more general improvements that happened over the last year. Stratum now uses canonical byte strings inside the P4 runtime protocol. This reduces the potential for confusion over padding Thanks, Brian. Simplifies message comparison significantly. For example, comparing a request to a reply, and allows for mechanisms like read-write symmetry out of the box. We also updated the core code handling P4 runtime mastership arbitration and are now fully compliant with the newest version of the spec, which is right now is 1.4. Stratum BFRT has gotten experimental support for metadata translation in conjunction with OpenConfig port ID paths, which are new. This allows using higher level abstractions like logical port numbers instead of physical port numbers within these P4 runtime messages. These features can make P4 programs a lot more portable across different ship models, as it's not tied to a specific port mapping, as well as it simplifies the requirements on the control plane, as a lot of less state tracking and translation is required there. Lastly, we fixed a couple bugs around P4 meter configuration resets and port ID values in the OpenConfig tree. And with that, I will hand it back to Brian.
Awesome. Thanks, Max. And thanks for all the great updates for the past couple of years, or last year or so. So let's change topics a little bit. And let's talk about how Stratum gets used today as part of, for example, ONF's SD Fabric project. Today, Stratum's primarily designed to run on the switching infrastructure, like the leaves and spines shown in this data center topology diagram on the left. These are the switches outlined by the orange box in the diagram. These switches are controlled by an SDN controller using P4 runtime and GNMI interfaces that Stratum provides. These are the interfaces we've talked about in previous Techinars and in many presentations prior. In SD Fabric, we use ONOS to control the switches and then provide a suite of applications to manage the devices and their forwarding tables. Stratum runs as an agent, a process on the switch, and provides precise forwarding control of the P4 defined pipeline. Then the Fabric apps can control traditional tables like routing and ECMP and ACL, as well as new ones that are introduced to manage in-band network telemetry, also known as INT, and data plane functions that have been overloaded to the switch ASIC or offloaded to the switch ASIC, like tunnel NCAP, DCAP, for example, like GTP tunnels for the 5G user plane. However, we don't today use Stratum on the servers in production. And the fact that we don't do this creates some challenges. For example, SD Fabric is not able to achieve convergence of the underlay and overlay networks. SD Fabric manages what's typically called the underlay network, and something else, like Kubernetes, manages the overlay. This makes it difficult to control, monitor, and verify the end-to-end path of a packet. There also exists a potential for configuration errors, such as when the network team updates the configuration on the switch side, the server or compute team may not make the corresponding change at the same time on the server side. So let's zoom in a little bit to a single rack in the data center topology we were just looking at. We can still see the top of rack switch at the top of the big black box, which is connected upwards to the spines and downwards to the servers. We still have our orange bounding box, which demonstrates where our network control domain is. On the server side, we have a NIC card, along with CPU, RAM, storage, and other peripherals, as you might expect. Traditionally, the boundary between the network infrastructure and the servers is the link between the NIC and the top of rack switch. But what if we could extend the control domain of the infrastructure into the switch? If we replace the NIC card with a P4 programmable data plane and a CPU to run the Stratum agent, we can push the boundary of the network from the top of rack to the top of server. Adding such a switch to the server solves some of the issues that we just talked about. Specifically, it provides a set of SDN interfaces for the server's network stack that makes it easier to control the forwarding behavior at the VM, container, or process level. We can more easily observe packets one step closer to their origin and verify the path of a packet end to end. This approach provides a new boundary between the network and compute teams, better isolating the networking from the tenant applications that share resources like the CPU and memory on the main board. You might be wondering if such switches exist for the server today, and I'm happy to report that they do. These cards are called IPUs, and they're available from companies such as Intel, AMD, NVIDIA, and others. So what is an IPU? Max talked about it, I just mentioned it, but for those of you that are not familiar, an IPU, or Infrastructure Processing Unit, is sometimes also called a DPU, or Data Processing Unit. And these are devices that go beyond the foundational or previous generation SmartNICs. An IPU is a chip that can be deployed on a PCI card along with high-speed Ethernet ports like QSFPs. In the picture here, the IPU is this big gray square on a PCI card, and you can see the high-speed ports like the QSFPs on the left-hand side. The IPU contains an embedded microserver and a P4 programmable pipeline. The IPU can virtualize higher level services like RDMA, NVMe, DPDK, and IPDK for applications. And it can also offload certain functions like crypto functions from the main CPU. The IPU is operated as a separate component from the server and can be managed out of band using its own dedicated management port. That's the small box on the left side of the card. The IPU's compute resources are physically isolated from the main CPUs as well. I already alluded to the fact that we might be able to run Stratum on the IPU. So next, we'll take a look at the API that we can use to program the IPU from Stratum's perspective. Intel's IPU can be programmed using an open source interface called TDI, which stands for Table Driven Interface. TDI is independent of any P4 program, P4 architecture, or backend target. Different targets are supported by pluggable backend implementations for the same front-end interface. TDI entries are constructed according to the TDI schema, often referred to as TDI.json. The parts of the entry schema that are related to P4 are generated by the P4 compiler from the P4 program, and the target-specific fixed functions like the traffic manager or QoS are provided by the vendor for each target, and those tend to be more fixed parts of the JSON. TDI is also available for P4 DPDK, and the backend implementation for that target will be open source. As we've been alluding to, we're planning to build a new Stratum target that leverages TDI. The TDI API is already open sourced and available for you to view and download on GitHub. The Intel team has been working on a project called P4OBS and has used TDI to control the P4 DPDK backend. The P4 OBS component that manages the target is called Infra P4D, and that was based on Stratum BFRT and refactored to use TDI. So if you've seen talks on P4 OBS in the past, largely you can think of that as being built on Stratum as a foundation. The team is currently extracting the relevant parts of the Infra P4D code and preparing to open source it to Stratum as a new Stratum TDI target within the next few months. TDI is designed to support a variety of targets, and this new Stratum TDI target will support P4 DPDK, the Intel Mount Evans IPU, and the Intel Tofino switch ASIC. Looking further ahead, we expect to see TDI on the FPGA targets and additional platforms from other vendors in the broader P4 community. P4 OBS and Stratum are synergistic projects, and there are several benefits to upstreaming this work back to Stratum. First, it will provide a higher performance software switch for Stratum users, which is a significant improvement over those who have used BMB2 and want to send larger amounts of data plane traffic. It will also make it easier for the P4 OBS project to consume upstream Stratum's fixes and enhancements, like the list we went through earlier in the talk today. Lastly, the Stratum TDI target opens the possibility of a unified software stack that can be deployed on CPU, IPU, and switching ASIC. I'd like to give you just a little bit of a hint of what the new Stratum TDI target looks like. So as I mentioned, we started with Stratum BFRT, so that's a good working mental model for you to start with. And this is what's shown on the left-hand side of the screen. This includes the common implementations of P4 runtime and GNMI services on top of Stratum's common generic switch interface. It also includes the managers and mappers that translate from P4 and OpenConfig messages to Intel's BFRT API. Moving to the right and looking at TDI, we're fortunate in the fact that TDI is a C++ interface that is very similar from a semantic perspective to BFRT. So we only need to do a little bit of refactoring, which is relatively straightforward, from BFRT managers to new TDI managers. Stratum TDI will introduce a new set of TDI managers and mappers that looks very similar to their counterparts on the left side. Putting everything together, we leverage Stratum's common northbound API services, adapt the BFRT-based target to TDI, and mix in the SDK for P4 DPDK or the IPU, and now we have a solution that can run on the server. Switching gears a little bit, let's talk about another Stratum roadmap item, which is Stratum's base operating system. As you may know, Stratum runs on Linux, but it isn't tied to any particular Linux distribution. Users have the flexibility to deploy Stratum on different distros, but it can be helpful for some users to provide a default one for them. For many years, ONL has served as that default base OS. We used the ONL v2 branch in Platform API, which unfortunately has fallen into a bit of a state of disrepair. There have been very few incoming commits over the past few years, and the underlying Debian distro and Linux kernel are showing their age. The main branch is a little bit better, but unfortunately not good enough for the needs of the Stratum community. For Stratum, Sonic has emerged as a better choice for the default base OS. It's based on Debian like ONL and is more actively maintained by a larger and more diverse community. Sonic publishes releases twice a year, and updates and fixes to the project are regularly backported to release branches. So here's what this means for Stratum users. For all releases up through the most recent one, which was the 22.06 one we did last month, ONL is the default base OS for Stratum. Users can continue to use ONL or any other distro that they prefer. For releases moving forward, starting with the 22.09 release in September, Sonic will be used as the default base OS. However, we aren't using all of Sonic. We're just planning to use the base Debian distro, Linux kernel, and Platform API. Most of the Sonic control plane services are going to be disabled. As part of the Stratum release, we'll publish specific Sonic images, just like we do for ONL today, along with their kernel sources. Stratum's Debian packages and containers will contain the kernel modules for recently supported Sonic images, as well as some ONL images for a short transition period. And for ONF CI testing and certification, we'll be moving to the Sonic base OS for qualifying and testing Stratum. Longer term, there are some opportunities to better integrate Stratum with Sonic. For example, we could create a PHAL adapter for Sonic's Python-based Platform API. We could also plug Stratum into Sonic CLI, which would allow users to configure and monitor ports, for example. And this is important because today's Stratum lacks an on-the-box CLI of its own. So using Sonics could help make human configuration and troubleshooting more easy. So now let's summarize. We covered three main points today in the Techinar. First, Max provided an update on the recent Stratum releases, including the June 22.06 release, and covered some of the major highlights from the last year, like our transition from Stratum BF to Stratum BFRT. Next, we talked about how Stratum could be used to control the IPU and the server, which could provide better end-to-end visibility and control on the packet path. And finally, we talked about two major roadmap items for the next release: the initial version of Stratum TDI for P4 DPDK and IPU, and a move from ONL to Sonic as the base OS that's provided by default for Stratum users. If you'd like to get more involved in Stratum, you can join the mailing list or the Slack channel. Stratum's TST also meets bi-weekly, and meetings are open to the community, so feel free to join one of those. For developers, as always, we welcome your pull requests, and for new users, the next-gen SDN tutorial provides some great insights on the Stratum interfaces and use cases. And finally, we'd invite you to help us review and test the new Stratum TDI target that's coming in later this year. And with that, Max and I can open the floor to questions. Maybe I can ask a question for you, Max. You mentioned that Stratum BF to Stratum BFRT is basically a drop-in replacement. But for a user that's been using the Stratum BF, what's involved in repacking the pipeline today?
Yeah, that's a good question. Let's maybe back it off and start with the actual replacement of the binary. And that actually is pretty simple. We always sim-linked Stratum BFRT to Stratum BF. So if you just install the Stratum BFRT package instead of Stratum BF on the switch, all your scripts should continue working because the binary is just there. So yeah, it's really just the packaging that has to change. And coming to that, PI or the Stratum BF packaging format comes from PI. That wasn't something we invented. It's an old format, and it's a quite inflexible format where you had to put certain magic bytes in a certain position, and then the library just was able to read it. And if you got something wrong, there was very little error indication. We decided to improve upon that, or try to improve upon that, and used a protobuf-based pipeline packaging format. Protobuf has many advantages over manually packing binary messages. One of them is the parser is automatically generated. So what you need to do today, instead of using the provided Python scripts from the PI implementation, I think it's called update pipeline or package pipeline, you can use one of our provided tools. It's the BF pipeline builder. That takes the exact same inputs. So you compile your program as normal. It gives you a bunch of outputs, JSON files, your P4 info, your binary file for the Tofino ASIC. Our tool takes all that and packages it into a single file. I think we could just call it pipeline.pb.bin. And that file just gets delivered over P4 runtime like before, and it should all work out. So it's really, instead of a Python script to package it, you use one of our tools that we provide both as a binary, as a Docker image on the Stratum tools, and you can also compile it yourself if you want. Hope that makes sense.
Cool, yeah, that makes sense. And do you have any preview into what this might look like on the TDI front?
Oh, that's a good question. I think it will be similar. I think it will be similar. We will probably provide a similar tool, TDI or TDI pipeline packer or something like that. So far we hadn't really any problem with the protobuf-based approach, so I think we will continue using that. Unless you have a better idea.
No, I was sort of just thinking the same thing. The format that we have for BFRT is probably very applicable here because for a lot of the targets, the backend output takes a similar shape.
It's also more flexible. I mean, once we start talking about having multiple pipelines or pipeline profiles, something that's supported in Tofino, the old packaging format is just not up to the task. And the protobuf version, it's super easy to extend. I think it supports it out of the box right now. So yeah, it's just the way forward.
Cool, thanks, Max. So moving to a question from Swati online. What does migration to Sonic mean to current Stratum users? Maybe I can start with this one, and then Max, you can fill in some of the details. So the migration to Sonic should be something that is relatively transparent to most users. And when I say that is most users interact with Stratum through its northbound interfaces, which are P4 runtime, GNMI, And they typically deploy it either as a Debian package or as a container, most as a container. So from that perspective, whether you're running on Ubuntu, Debian, or some other distro like Sonic or ONL, you load your container with a start script, and then you get a set of interfaces that you can interact with from the control plane. From the operations perspective, installing a Sonic image is basically the same as installing an ONL image. You use a bootloader like Oni to install the image. The image comes up, and you get a Linux bash prompt. So we don't expect there to be too much of a transition that's required. But Max, do you want to fill in any other details?
I would say if you're currently using ONL features, like some of the more platform-specific APIs to rely on fan control, PSU statistics, QSFP statistics, those at the moment will unfortunately go away once we go to Sonic. Not forever necessarily. Brian, you touched upon the topic of creating a Sonic PHAL, and that might very well happen in the future. That was also one of the reasons we wanted to go to Sonic, because it has such a wide supported base of devices, much larger than ONLP, I think, and also better supported at this point. But right now, with the next release, I would expect if you depend on ONLP APIs, there will be some breakage. It's unlikely because those APIs were really good and they're probably broken already, but just putting it out there.
Maybe diving in a little bit more to the specifics. So for our Intel Tofino targets, we've generally preferred the BSP for managing peripherals that are related to the ASIC. So even on ONL today, for example, on the wedge switch, we use the BSP that's integrated as part of the P4 Studio to look at peripherals rather than ONLP. So for those targets, if you have a BSP and you're planning to continue to use that, then you probably weren't, unless, like you said, Max said, unless you were configuring or reading your fan through GNMI or your PSU status through GNMI, there's not really anything you'll observe differently. Most of the boards have their own fan controllers and power controllers and infrastructure management agents that run on the box. Sonic's no different. It either runs on the mainboard CPU or on a BMC. So yes, for some peripherals on some targets, you may have less control and less visibility, but for the most part, on the targets that we've been looking at and that we know of in the community, we don't anticipate this being a significant challenge. And like I said, if it is, you can always still use ONL. There's nothing preventing you from doing that. So this is just the default option that we recommend for users and where we do a lot of our base testing. Did you have any questions, Max? I threw one at your way.
Give me a second. Yeah, I have one. I think on the slides you said, or we said, that Stratum TDI will also support the Tofino ASIC. To me, that means we will have two paths to the Tofino ASIC, right? Both Stratum BFRT, not BF anymore, and Stratum TDI. Do you expect a gradual transition to TDI and away from BFRT in the future, or do you think those will live side by side? What are your thoughts?
Yeah, that's a really good question. And I had this conversation fairly recently with the team that works on the SDE. So right now, BFRT is the canonical API to program Intel Tofino. It's the one that's best supported and most recommended by the platform team. That being said, they've been working pretty hard recently to build up in parallel a TDI-based stack. And for a lot of the features that, for example, we use in SD Fabric, that TDI stack may already be at feature parity. So I think it's sort of similar to our transition from BF to BFRT. We'll have a parallel stack that's built up on the ASIC. They do have plans to maintain a BFRT to TDI translation layer for Intel Tofino. And the plan with that is that for customers who built BFRT-based applications or tests, those would be able to, they can run those directly on the TDI target as they build it out and qualify it. So I think what we'll see is, over the next couple of years, a transition of energy and effort from BFRT to TDI on Tofino. And yeah, I mean, the support that we'll see on Stratum TDI initially, maybe it won't be quite at the same degree of feature parity of BFRT today, but just like BFRT evolved and matured rapidly, I'd expect the same for TDI.
Yeah, that makes sense. Thanks for answering. I think the same. Like, it will be a gradual thing where there might be one new feature that's TDI only, and then there's a second new feature, and then it's faster or more stable, and it will be a natural transition to it once it's getting better and better. And BFRT will be in maintenance mode, probably. Yeah, thanks.
Yeah, I mean, the other thing that's kind of interesting is that when you use the same sort of very generic API across 3 targets that look very different, meaning DPDK, which is CPU, IPU, and switch ASIC, inevitably, when we get started, there are going to be differences that are required from initialization, bring up, mapping, etc. And so we may have a couple of flavors of Stratum TDI in the beginning, but eventually, I think the goal for the team is to have one Stratum TDI, and then you just bring a different library in, and the library provides the correct initialization behavior for the independent target. So yeah, I mean, we may have a few flavors of TDI in the beginning, is what I'm trying to get at, but eventually the goal is one TDI target. All right, so a couple of questions online. Will there be a migration guide? I'm assuming this is from ONL to Sonic. Do you want to take that one, Max?
Yeah, sure. Yes, there will be a migration guide. Probably focus on will and not is. We're still preparing that PR. It's actually happening right now live on GitHub with our team members and us too. Yes, we will do a write-up on what to do. I'm not super sure on the migration part. There will be for sure an installation guide, like how to bring up the switch, how to install stuff, how to install Stratum, how to prepare it, what to disable on the Sonic side. Yeah, so that I can say. There will be detailed instructions how to get started. For migration, I think we kind of mentioned that we don't think there will be a lot to migrate per se. So I'm not sure. We might touch upon that. If you think, or if anyone thinks there's parts missing, you're always free to open GitHub issues, ask questions, join us in Slack, and we can certainly provide such a guide if there's interest. I'm not saying we're not doing it. It's just right now we might focus more on a not new deployment guide. But yeah, if there's interest or need, sure.
Cool, thanks, Max. Another question from online. Is there any advantage of TDI over BFRT? So this is a good question. So maybe we can first talk about ways that they're similar, and then we can talk about some advantages. So both BFRT and TDI are table-driven interfaces. They're standard insert, modify, delete type APIs that use a generic entry format, which is like adding rows to a table. There's keys and data elements that go into a row. You can think about how in a table entry that might mean you have your match criteria and your actions and counter data as entries in this table. So TDI was, as I said, it's very similar to BFRT. I think it probably drew some inspiration from BFRT. And if you actually look at the two APIs side by side, you'll see they look very similar. It's just some namings and structure and semantics are slightly different. BFRT is actually open source. The headers are open as part of the most recent P4 Studio release, which was 9.9.0, and you can find it online on GitHub under OpenTofino. TDI, as I said, is open source, so you can compare them if you want. I would say the biggest advantage of TDI over BFRT is TDI is intended to be a open source community focused API. We're currently discussing adding TDI to the P4 API working group under the P4 consortium, which would involve both managing the C header files as well as a spec document, where that spec document has semantics and certain behaviors that are expected across targets. And while we're really only seeing Intel targets for TDI today, I think there's a decent chance, or there's some chance that over the next couple of years, we see other vendors' targets adhere to the same runtime API. A lot of switch vendors, IPU vendors, DPU vendors are sort of realizing that SDKs that are aware of networking semantics are less valuable on a programmable, like a P4 style pipeline. And so a lot are moving to these program or pipeline independent APIs that get filled in by a contractor schema, like our P4 info, our BFRT or TDI JSON files. So yeah, I mean, I think the advantage really of TDI is it's an open community standard. It already supports more targets, P4 DPDK, IPU, and Tofino. And longer term, hopefully that will be a runtime C++ interface that the community rallies around. All right. Next question, also related to TDI, from Narada. Any sense as to whether Broadcom will adopt or support TDI? That is a great question that I do not know the answer to. So I think the interesting thing, you know, I don't know if they'll adapt TDI. Maybe not. One thing I can say about Broadcom is the trends that I was just mentioning, which is a move away from networking semantics in the interface to independence, is something we've seen, you know, with Broadcom too. They have a programming language for their ASIC called NPL. The most recent generations of ASIC are increasingly programmable and allow users to put in their own ACLs as well as new tables, just like we described for other ASICs. And Broadcom also has an interface called SDKLT, which is SDK logical table. So that's an interface where you have a schema that's independent from the API itself. And it sort of follows the same principles as TDI, but is sort of different in its manifestation. So yeah, I know most Broadcom customers still prefer the traditional SDK, but you know, I think that I don't have any clear answer yet as to whether Broadcom will or won't adopt TDI. I guess we'll have to see. Any other thoughts, Max, you want to add before we close out?
No, I think we're good. Thanks for the questions. And Yeah, I'll let you close out.
Sure. Okay, well, thanks everyone for joining the Techinar. Thanks for your great questions. And we look forward to working with you on future versions of Stratum.
Thank you from me as well.